start our demonstration. So this part, this is our 2.5 axis prismatic part. Here, we're going to work our way from left to right from the program tab. For the machine, in 2.5 and 3 axis, you really only have one option. Keep it at 3 axis. If you only have Express, Standard, or Expert, you will only have one option called 3 axis. So that's what it's going to be for both 2.5 and 3 axis. And obviously, there's other options here that we'll get into those in a more advanced setting. So it's going to be set to 3 axis by default. Pick OK. So what I was mentioning here in the setup, you have by default, you have a setup 1 predefined anytime you open a part file or open a new file. And you'll see that if we turn this triad off, you got 2 toggles down here, one for the world coordinate system. So there's your world origin. And then by default, the setup is located at that location. And the X and the Y in the Z axes will align with your machine axes. Typically, if you're standing in front of the machine, X is to the right, Y is looking at the machine, and Z is up. So let's go ahead and do some 2.5 axis operations. We'll go ahead and start with a face top. So in face top, it just automatically determines where the top of the part is, where the top of the stock is, and it'll face that off for you. Let's go ahead and use a face mill. And for these examples, we're not going to get into feeds and speed values. We're just using the default parameters. In the clearance plane, you have options to determine how you want the clearance plane to be calculated. Typically, in most cases, you just select automatic. And then for transfer methods, you'll set it to clearance plane. So for the cut parameters in facing, you have a stock allowance and a tolerance. In facing, typically, you know, the tolerance doesn't really come into play a whole lot because the tool is going to extend past your part in the XY axis anyway. Stock, again, is measured in the X and the Y. It's not going to come to play in this part either, not in facing. So let's go ahead and we'll set multiple step overs, and we'll let the program compute the cut angle. And for the cut levels and face top, we're going to tell it that the top of the stock is going to be the top of the cut, and the top of the part is going to be the bottom of the cut. And for entry and exit, you got various options for entry and exit for the toolpath. And again, you got advanced cut parameters. Let's go ahead and generate this. So you'll see that we got a facing operation located on the top. If you don't want to do those retracts, you can change your cut direction to climb, conventional, or mixed. It retracts and starts a new cut if you're trying to maintain a climb or conventional. So we'll set it to mixed, and you'll see that there's no offsets. And let's go ahead and simulate this real quick. Slow this down some. And that's our facing operation.
Actually, that's our face top operation, which is really used for facing to the top of your stock. So if you have a, not a very smooth stock model or a stock, workpiece, and you want it to face it so it's to the right level, this is what you use. And then we also do have a facing operation, which you can use for core type of parts.
Okay, let's go ahead and do these pocket areas. We got 2 blind pockets and 2 through pockets. Let's go ahead and do a 2.5 axis pocketing operation. And you'll see on the dialog, you have different buttons down here, different ways of selecting your control geometry. If you have flat areas, the fastest way is just use the select flat area regions button, pick the bottoms of the pockets, and it will calculate each perimeter curve for the pocket. So for the tools, we're going to use a flat end mill this time and use the default feeds and speeds, same clearance plane definition. For pocketing, obviously you have a tolerance. Each operation will have a tolerance value, and they come into play more often than not in different operations. and we have a stock value left. We're going to go ahead and leave no stock, so we're going to cut right up to the sidewall of the pocket. And also you can enable cutter compensation. We're not going to get into that in this basics class, but we will probably talk about this in the future. We're going to use an offset cut pattern, a mixed cut direction. We're going to start on the inside of the pocket, and we're going to step over 25% of the tool. And let's go ahead and look at the cut levels. Where is your geometry that you selected? It's at the bottom. So that's how that works. Let's think about your geometry. Where is your geometry in relation to your cut depth? So the total cut depth, you can go ahead, if you know what it is, you can enter it, or you can use the pick button and select 2 points. Doesn't matter which two, top and the bottom, and it'll calculate what that depth is. So it's 0.551 inches. So right now, if you leave it like this, it'll only cut one level at the bottom of the pocket. You can use this slider to add multiple cut levels. So let's go ahead, and for the pocketing, entry, and exit, you have different entry methods. We're going to leave it at a path entry and a linear retract. Again, since we have radii in this pocket, we're going to use arc fitting, and by a standard arc fitting tolerance will be 2 times your cut tolerance. So this tolerance is 1,000th, so we're going to use 2,000ths for arc fitting. So let's go ahead and generate that. So you see, sorry about that. So you see your toolpath. Let's go ahead and show that. And let's go ahead and go to multiple cut levels. Just 1 second. Sorry about that. So you see this icon here allows you to see the cut levels inside of the part. So you'll see that we have multiple cut levels going down to the bottom of the pocket. So let's go ahead and run a simulation on this. We'll turn the toolpath off. And so you can see the entries and the exit at each cut level. Just speed that up a little bit. Okay, so there's our 2 pockets, and we got 2 other pockets. So what we're going to do is we're going to right click and clone this pocket, and then we're going to edit this pocket. We're going to remove that geometry, and we're going to add this geometry here, and we're just going to select the top edge of these 2 circles. And for the tool, we'll use the same tool. Everything's going to be the same. Tolerance be the same. We're not going to have any stock. 25% step over. The cut levels. This is a deeper cut level because it's going through. Let's go ahead and double check what the depth is. So it's going to be approximately 748, and we'll just make a couple of cut levels. Again, we'll use a path entry for the pocket, and we're going to use cut arc fitting. So you see,
there was a question on what is arc fitting. I
okay.
just wanted to quickly explain what that is, and
okay. Let me make a correction here real quick. Location of cut geometry, I picked that bottom from the last operation, but it's not. The top of the cut is the control geometry, so I need to change that to add top and generate. Okay, arc fitting. What's going to happen here is when, if you don't have arc fitting enabled, it will create linear segments to cut that part. So the perimeter of this circle will be small facets going around because it's using.
Unless I want to qualify that statement,
okay.
Unless that perimeter actually is an arc. If that was a true arc, then it's not going to be linear cuts. It's going to be the toolpath itself is going to consist of arcs. But if we had linear segments as part of the perimeter, then the toolpath will also be linear segments. In those cases, you would want to use arc fitting to actually fit arcs after the toolpath is computed.
Mm-hmm. Okay, so let's go ahead and move on to our perimeter of the pocket of the part. We're going to use a profiling operation, and we'll just go ahead, and we have a curve right here. We're going to select that, and we're going to use the same tool, cut parameters. It's going to be, that's fine. You use the midpoint of the longest side for the start point. We're going to use a 3D model to detect which side to cut. And for the cut levels, again, we're going to select the top and the bottom. We'll make an adjustment here, and entry and exit. We'll go ahead and use lines and arcs, and we're going to put those entry exits at each cut level, and we're going to use an offset overlap to clean up the area where you started cutting. And again, we're going to use arc fitting. We'll go ahead and generate that. So you'll see that the tool, when it goes around, a little bit too fast. When it goes around, it overlaps the start area and cleans up this part. So let's go ahead and just simulate those all the way through.